This is section 4.6 on performing operations with complex numbers. What you're going to learn today is a new value called I. This new value is called I, and it will now allow us to complete any square root values that have a negative number underneath the radical. Typically when we saw that negative number underneath, we said no solution or we can't solve that. Now we're actually going to get an answer for that. So anytime we see the square root of a negative number, we're going to break it up into pieces. We're going to take that negative sign out, and then we're going to take that negative one out and break the regular number up into whatever pieces we can. Anytime we take that square root of negative 1 out, we will always replace that with the letter I. The other thing that I want you to remember too is that when we start doing our multiplying, anytime you have I squared will be worth negative 1. All right, so let's see how this is going to look. Square root of negative 8. We're going to break that up into pieces. Now typically when I do my pieces, we like to do them underneath, but you can do them however you need to. Square root of negative 1. 8 will be broken up into square root of 4, square root of 2, square root of 4 being the doable piece. Here's I, here's 2, and then the square root of 2 we can't do. And then when you write your answer, plain numbers always go in front of the I term, and then the radical will always sit in the back. Square root of negative 24, same thing, pieces, square root of negative 1, square root of 4, square root of 6. You're looking for your factors of 24. Pick a factor that you've got as a perfect square. 4 would be that value. I term, again, 2 for the square root of 4. Square root of 6 you can't do, so your final simplified answer would be 2I square root of 6. When you solve equations, we're going to be using our square root method on both sides for a lot of these, and then when you're square rooting, you're going to find that you will have these I terms that will show up. So for instance, in this first one, solving for x, we're going to move our 18 to the other side first. 2x squared equals, what is that, negative 90? X squared equals negative 45. Square root on both sides. We've got negative 1, 9, and 5. 3I square root of 5. The one thing that you want to remember also, whenever you do square roots on both sides, you have to remember to bring in a plus and a minus sign. That's extremely important. You've got two values when you square root, and then that plus and minus sign will sit in the front. So plus or minus 3I square root of 5. Down here, subtracting our 11 on both sides first. X squared equals negative 8. Square root both sides. X equals, there's that plus and minus sign right away. Then you can do your pieces. Negative 1, 4, 2, plus and minus 2I square root of 2. Adding and subtracting is just like any other variable. So treat your I term just like you would treat an X term. If you find I terms, you're going to try to combine those. The one issue that people sometimes have is that they forget when they've got a minus an entire quantity, that negative sign has to transfer through to both of these. That becomes a negative 24, and then negative negative is positive 9i. A lot of people miss that. The other mistake that sometimes people make because they get in a hurry is that they look at these two sets of parentheses next to each other and they think that they need to do FOIL on that. This is not 12 times negative 8, 12 times 3. You do not do that. This is just an addition question. If it helps you to rewrite it and put those like terms together, then you can go ahead and do that. Not doing FOIL. 12 plus negative 8, negative 11i, plus 3i. Now you have your like terms sitting next to each other. 12 subtract 8 is 4, negative 11i plus 3i is negative 8i. There you go, 4 minus 8i. Down here, let's complete this subtraction question. We've got 15 minus 9i minus 24 plus 9i. Without rewriting this, putting the terms next to each other, just pull them out of the question. 15 subtract 24, those are your like terms. Negative 9i plus 9i, Those are like terms. Negative 9 plus 9 cancel each other out. And your answer to this one is just negative 9. When you do multiplication or distribution, the thing that you want to remember, and I mentioned this on the first slide, is that anytime you have I times I, that gives you I squared, and I squared is worth negative 1. So you have to replace that you have to replace that I squared with negative 1. All right, distribution. Again, just like any other distribution with an x term, you're going to do that same distribution with your I term. Negative 5i times 8, negative 40i, negative 5i times negative 9i, negative negative is positive, 45i squared. We did just say that I squared is worth negative 1. That gives you a negative 45. And these are not like terms now. One of them is an I term, one of them is a plain constant, so you cannot go any farther. If you're doing FOIL, same rule with FOIL with your x's as with your I terms. Negative 8 times 4, negative 8 times negative 7i, there's positive 56i. Underneath here, 2i times 4, 2i times negative 7i, negative 14i squared. I squared is worth negative 1. This then creates positive 14, negative 32 plus 56i plus 8i. Your plain numbers, negative 32 plus 14. There's your plain constants that go together. Negative 32 plus 14, and then 56i plus 8i, 64i. Complex conjugates, this is the last thing that we need to talk about in this particular section. Complex conjugates are just like square root radical conjugates. If you have a plus bi as a term, then you also have a minus bi as its complex conjugate pair. You want to look for positive, and then the opposite sign, negative, would be the conjugate pair to that. Remember that you cannot keep an I term in the denominator, just like you cannot keep a radical in the denominator. You need to rationalize that. So in this first one, 3 plus 4i over 5 minus I. We look in the bottom. The bottom shows that we've got an I term. Can't keep the I term. We need to multiply by its conjugate pair. 5 minus I is 5 plus I as the conjugate pair. Multiply on the bottom, we have to multiply by that same thing on the top as well. I'm going to do the bottom first here. Remember, when you do conjugate pairs, the inside-outside terms always cancel each other off. So the only things we need to worry about are 5 times 5, negative 5i, positive 5i, those cancel each other out. So the only other term I need is right here. Negative I times positive I, that's negative I squared. I squared is worth negative 1, so I have negative of negative 1, that's plus 1, which then gives me 26 for my bottom. Okay, so 26 is our denominator. Now on the top, we can do the complete FOIL. 3 times 5, 3 times I, 4i times 5, 4i times I, that's 4i squared. I squared is worth negative 1, that means this is negative 4. So we have 8 subtract 4 is 4. 3i plus 20i is 23i. So we should have 4 plus 23i over 26. Okay, I need to go back here a second. Let's change this. You probably caught this as I said it. 3 times 5, this is 15 right here. Sorry, 15 minus 4 is 11. This is really 11 plus 23i over 26. Now it's right. Okay, so you probably caught that as I was writing, hopefully. All right, down here, let's do one last question. I believe this is our last one. Yeah, one last question just to make sure we're on track with the conjugates. 5 plus 2i over 3 minus 2i. Conjugate pair to 3 minus 2 is 3 plus 2i. and then 3 plus 2i on the top as well. Remember, whatever you do on the bottom, have to do on the top. Let's do the bottom first. 3 times 3, there's 9, and the only other piece I have to do is right here. The rest cancel. Negative 2i times positive 2i, negative 4i squared. I squared worth negative 1. 4 times negative 1 is negative 4. Negative negative is plus 4. So this is 9 plus 4 gives us 13 for our denominator. And then on the top, let's see if I can get this one right now. 5 times 3, there's 15 again, instead of 8 like I had up there. 5 times 2i, 10i. 2i times 5, oh, this is a 3, sorry, this is a 3. 2i times 3, 6i. And 2i times 2i is 4i squared. I'm going to move this over a little bit. Okay, 4i squared is really negative 4. I squared is worth negative 1, so that's negative 4. 15 minus 4, there's 11. And then 10i plus 6i is 16i, and we had a total of, what, 13 on the bottom. The only other thing that you would really ever have to look for would be if you could reduce this fraction right here. The only way you could reduce this fraction would be if all three numbers have something in common. So the 11, the 16, and the 13 would all have to have something in common. They don't in this case. Let me just give you a different example of when that might happen. For instance, if our last answer would have said 12 plus 16i over 8, then you could reduce in all three places. Each one of these three numbers would have something in common. They all share a 2. So I could divide by 2, divide by 2, divide by 2. Could I have divided out something higher? Sure, I could have taken out the 4. So if we would have taken out, or in this case, take out another 2, 3, 4, and 2 leaves you with 3 plus 4i all over 2. That would have been the reduced form to this sample right here. Okay, so that is the one thing that you need to look for when you get to this very last stage. Can you reduce everywhere by all three numbers by the same thing? If I look back up at this one up here, 11 plus 23i over 26, 11, 23, and 26 do not share anything in common, so we can't reduce that one any farther as well. Okay, so there's your information dealing with complex numbers, that I term. Remember, square root of negative 1 will now be I, and anytime you have I squared, remember I squared will be worth your negative 1, and then you'll have to carry out the like terms once you take care of that negative 1 term. All right, so that's it for section 4.6. You can go ahead and start your homework for this.